My name is Ben Osborne. I'm a software architect at Milliman IntelliScript. If you're not familiar with Milliman IntelliScript, Milliman is the parent company of IntelliScript. They're based in Seattle, and they're mainly offer actuarial services. And IntelliScript is what we call practice within Milliman. We offer software as a service products that are mainly used by the insurance industry, and we're based in Brookfield, Wisconsin. I have to qualify that because this is the Midwest conference, and there's a Brookfield, Illinois as well. Yeah, I'm not ready to advance to that one yet. So I'm a software architect now, but I started out as a developer. And at my first job out of college is when I did my first database migration. And so at that time, my company was running classic ASP websites with Microsoft Access databases, and that actually worked as long as there were roughly a couple hundred users at max at any given time. And once it got up to about 1,000 users, that's when things started to seize up and stop responding. And so that led to my first database migration, which was during our busiest time of the year. And that's when we, with some unplanned downtime, had to upgrade our Microsoft Access databases to SQL Server version 2000. So that was my first experience with SQL Server. And so with this story that I'll be telling today, that's also involves SQL Server, but in this migration, we're moving from SQL Server to Amazon Aurora Serverless. So fast forward to 2023, and IntelliScript's business had an idea for a product, and this product was going to require a very large, hundreds of millions of rows data sets to be hosted in the cloud, and it was going to be a read-heavy workload, and the database had to perform under heavy load, heavy and sporadic loads. So we kind of knew all the pieces of our architecture, except for the data store. So this is a familiar pattern that we use. We have API gateways backed by Lambdas. And so the data store was the question mark. And at the time, IntelliScript was just kind of starting our migration to the cloud, and we didn't have any databases in the cloud at that point. And so we didn't have a standard relational database in the cloud. And so we needed to figure out what we're going to use for this data store. And IntelliScript does have a lot of SQL Server databases on-prem. We have lots of expertise in SQL Server, and we like it. We're used to working with it. And so when we first needed to release this product, we went with AWS RDS for SQL Server. And it worked well. The product was released. The business was happy, and everyone was happy, except for the FinOps engineers. Some of them are in the room today. So this database instance was the single most expensive AWS resource that we had for about a year. Month after month, it came up as number one on our cost report. So as much as we like SQL Server and as much expertise we have in it, it just didn't seem like it was going to be our go-to relational database for the cloud. And so looking at the different options that AWS offers, we needed something that would be, for one thing, cost-effective, scalable, and if possible, serverless. And so given the options that AWS has, the most promising resource, the most promising service was Aurora Serverless Postgres. So Postgres was just a preferential choice. Aurora Serverless, it comes in a MySQL version as well, but Postgres seemed like the better fit for our use case. So if we wanted to ratify this Aurora Serverless as the standard for IntelliScript's cloud relational databases, we had to prove that it would work with this workload. And this workload is a little bit unique because some of the things I described about it is a very large denormalized data set and had to perform under heavy load. But we kind of knew that if Aurora proved viable for this workload, it would probably be able to handle anything else we throw at it. But we needed to prove that out. And we also needed to establish a toolkit for working with Aurora Serverless. But to see what I mean by toolkit, I'll show you our SQL Server toolkit. So these are the tools that we have established for working with our SQL Server databases. Over many years, we're familiar with them, and they worked well. They're tried and true. So I will kind of describe these so you kind of know what they all are, because then it'll make sense what we replace them with. So this first concern, which is provisioning and management, for our kind of legacy SQL Server world, we generally just provision things manually. We don't have a infrastructure as code solution or tool for our on-prem legacy environment, so that's just manually provisioned. I mean, maybe there's some PowerShell scripts, but it's mostly just manual. And then the next concern is .NET tooling. So we are a Microsoft shop, Windows Server, as I mentioned, SQL Server. That's one of the biggest pieces, and .NET. So if you've worked with SQL Server via .NET, you're probably familiar with the Microsoft SQL Client Library. It's just the Microsoft's ADO.NET provider for SQL Server. And then there's another library that we heavily use called Dapper. Dapper is, you can think of it as a micro ORM. It allows for very concise querying and sending commands to SQL Server in with some good syntactic sugar. It's a lot more lightweight and less opinionated than something like Entity Framework, which we don't use very much or at all. So with authentication, for authentication, we're using GMSAs. So if you're not familiar with that is a group managed service account. And so that is a Windows Server concept. So the nice thing about GMSAs is that our Windows services can run under these service accounts, and then they can be mapped to users in SQL Server. And then when our applications want to authenticate to SQL Server, they could use trusted authentication. And the benefit of that is that there's no credentials stored in the connection string, which is nice, and InfoSec likes that. For ETL, in the SQL Server world, we use both SSIS, which is Microsoft's tool of SQL Server integration services. That we also use our custom lightweight ETL solutions that we write in our primary language, C#, and for that we use the library Dapper Plus, which is the paid version of Dapper that gives you bulk operations. And the main reason we're kind of have essentially moved from SQL Server integration services to our custom ETL solutions is that having an ETL solution written in your kind of primary programming language tends to be more maintainable and more developer friendly. So that's why we choose that. For migrations, so just to clarify what I mean by migrations, some people might call it deployment, but that is making changes to your database, schema changes, new columns, new tables, that type of thing. So for migrations, for SQL Server, we use SQL Server Data Tools. That is a state-based migration tool that Microsoft creates. It works well, but it's only compatible with SQL Server. And then for monitoring, we use Datadog. Datadog is IntelliScript's application performance monitoring platform. We see kind of all our database telemetry flow into that. So that is the SQL Server toolkit. So in order, as I mentioned before, if we wanted Aurora Serverless to replace and become our go-to relational database in AWS, we need a toolkit to address all these concerns in the Aurora Postgres world. And so I'll show you what we've come up with. So for provisioning and management, so for that we're using Terraform. That was a foregone conclusion. Terraform is the infrastructure as code tool that IntelliScript is using for all of our AWS resources. And when we use Terraform, we like creating modules to create guardrails for developers, but also have opinionated defaults so that developers can quickly provision something like a Aurora database cluster without having to agonize over dozens of configuration settings. So for .NET tooling, we are using NPG-SQL. So NPG-SQL is the equivalent of Microsoft Data SQL tools. It is the most popular ADO.NET provider for Postgres databases. There are others. NPG-SQL is the most popular, and it works well for us. You might be surprised that Dapper is not on this list. So Dapper does work with Postgres, but it works when you're using generally raw SQL with Postgres. When you have to start using compiled commands such as functions and stored procedures, that's when Dapper doesn't really work very well with Postgres. So I don't have time to get into the kind of the details of why that is, but if you view my slide deck, some of my unused slides kind of cover that. So that led us to creating our own library to extend NPG-SQL. It's basically syntactic sugar that allows developers to quickly create Postgres commands using a Fluent API. It's not as nice as Dapper's concise syntax, but I think it's pretty good. For authentication, we're using IAM. So with Aurora Serverless Postgres, things might be a little bit different with MySQL. I don't know, but there's three options for authentication. There's usernames and passwords, which we don't want to use because that's regressing from our trusted authentication with GMSAs. We don't want to get into a situation where we have to protect database usernames and keep them in connection strings and that type of thing. And another option is Kerberos. That seemed like the most complex option. Kerberos requires something like Active Directory that we'd have to connect our on-prem Active Directory, and it would be complicated, and we don't want to do that. We want to retire our Active Directory, so it's not going to be around forever. So that left IAM. So that's what we went with. ETL. So for ETL, we're using both AWS Batch and AWS Glue. So AWS Batch is nice for simple, lightweight ETL jobs. We can write them in C#. We can deploy them as Docker containers and run them in AWS Batch via Fargate. AWS Batch jobs run for up to 2 weeks, and so that's plenty of time for any ETL job to run. For more complex jobs, we will use AWS Glue. I think we haven't had the need for that yet, but that is kind of Amazon's ETL solution, their standard ETL solution. For migrations, we are using Liquidbase. So Liquidbase is an open source. Well, there's a paid version and an open source version of Liquidbase. We're using Liquidbase open source. That's a migrations-based deployment tool. We originally went with a different tool because I blame Liquidbase for this. I hope they're not sponsored today, but Liquidbase does not do the best job of promoting their free open source version. You can understand why. They want people to buy the pro version. So we originally thought that the Liquidbase open source version wouldn't do everything that we needed to do. But so we revisited that decision this year, and we found that it did only through using it. And so Liquidbase is now kind of our standard database migration tool. And then for monitoring, we are using Datadog. That's still the standard. That is our application performance monitoring platform. It works well for us. But then in addition to that, we're using AWS Enhanced Monitoring and Database Insights. So that's just some additional dashboards that are just built into the AWS Web Console. Database Insights in particular has some really good information that doesn't necessarily flow into Datadog, such as the most expensive SQL queries, and you can view the actual SQL that is the relatively poorly performing SQL that you can use that to then optimize it. So with that tool chain, we were able to migrate our SQL Server database to Aurora Serverless, and we did see cost savings of about 65%. I forgot that I was going to just define, I think most people probably know this, but to define like some of the terms I've been using, but So AWS RDS is Amazon's relational database service. Yes, please. That's a good question. I will talk about that shortly. Yeah. So in terms of so AWS RDS is Amazon's relational database service. So if you want to get provision a standard version of a database engine, SQL Server, Oracle, MySQL, use AWS RDS. If you want a Amazon Aurora database, which is an AWS optimized, it's a cloud optimized version of either Postgres or MySQL that's provisioned, then you use Amazon Aurora. And then there's Aurora Serverless, and that's the one that we migrated to. And that is the serverless version of Aurora. It will instantly scale based on demand, and so it's very cost effective because as of last November, it can actually scale down to 0 when it's not being used at all. So that is kind of like the migration story. It was a success. We had those cost savings. Your question about performance that kind of leads me into my first lesson learned. Okay. So the first lesson learned, it's a shocker. It's SQL Server and Postgres are different. You probably wouldn't have thought of that, but we definitely expected syntax differences. They're both SQL, of course, but they're different flavors of SQL. We knew that we'd have to learn the Postgres syntax. There's features that are missing from Postgres that we use in SQL Server. Postgres obviously has many features of SQL Server Postgres also has features that aren't available in SQL Server, but we don't use those yet because we haven't really mastered Postgres. But one of the features that was very useful for us in SQL Server was aliases, which is a name that can point to an object such as a table, and then you can query against that alias. And then whenever you want to, you can just change the alias to point to like a different table, and that lets you do things like zero downtime ETL, where your consumers don't have to really know what the active and inactive table is. Postgres doesn't have that feature. Postgres, Aurora Serverless Postgres does have a blue-green deployment feature that might actually help us with doing a blue-green zero downtime deployment, but we haven't used that yet, but we probably will relatively soon. So indexing limitations and performance differences. So there is a big difference in performance. I mentioned this workload that we migrated is an extremely denormalized data store. We're talking as I mentioned, hundreds of millions of records, and one index that includes over 50 fields. And so with SQL Server, an index can have 32 columns, but you can include additional non-key columns in that index. And so that's what we were doing with this data set. With Postgres, there's a hard limit of 32, so we could not use that index for our Postgres. We tried a bunch of different things. we tried using different indexes. You take, instead of that 150 field index, creating like 3 smaller indexes. We ended up having to normalize the data to a significant degree. And you might say, well, that's not a bad thing, right? You should normalize your data. We didn't have to normalize with SQL Server. It performed fine denormalized. So that's not a knock against Aurora Serverless. It's a trade-off. You know, it is serverless, and so there's things going on that I don't understand under the hood. But we had to normalize data to a significant degree to get it to perform, acceptably. I would say the SQL Server's performance was still better, but performance is acceptable with Aurora Serverless. So that's the first lesson learned. All right, next lesson is wait, did I skip on something? Okay, have production scale data in pre-prod environments. So some people are going to be like, well, that's a no-brainer. Of course you want that. And other people are going to be like, well, that's excessive. Why do you need that? So for SQL Server, we generally have needed production-like data in pre-prod environments, but not production scale data. We generally have not been, if something performs well in a lower environment with say like 10% the size of production, in SQL, it would generally run fine in production. We don't run into any surprises. Well, that was not the case with Aurora Serverless. We were surprised many times when trying production. Things that work perfectly fine in lower environments just would not work in production for whatever reason. So that's one of the lessons we learned. If we would have had production scale database in lower environments, we would have found these things out earlier. And that may involve writing a generator to generate production like data, but it's probably worth it. We actually haven't done this yet. It's on my plate. I got to do that pretty soon. But if you're gonna go this route, I think that's a worthwhile investment. And then that also affects the ETL processes that I mentioned. So if we have a custom ETL process running an AWS batch, in all lower environments, it runs just fine in like a couple hours. But when it has to run for days on end, because the scale of data is so much bigger, things crop up that did not crop up in lower environments. And so making those ETL processes like pausable and resumable becomes important when you might not have needed that before. The next lesson learned is IAM auth can be complicated. So I mentioned that IAM is the auth we went with just because it's preferable to the other options. But with trusted authentication in SQL Server, it's really nice. You have a static connection string. It's an environment variable. It's a config setting. So moving to IAM, it is different because instead of that password in your connection string, it's an auth token which you have to request from an RDS endpoint. That auth token is good for 15 minutes. And so instead of just having a static string in your app's environment variable, it's something that you've got to construct and then handle the expiration life cycle. We created a library to allow developers to get an authenticated connection with minimal code. So that's something that I would recommend so that your developers don't see IAM auth as like a degradation of their quality of life. And then having a break glass access protocol, so emergency access. So if you have to give access to a user who needs to say log into the database with an IDE to take a look at something to see if something's going wrong, if something's not performing, have a protocol for that. If assuming that you want them to log in with IAM authentication as well, you don't want to have to give them your master database username and password because you generally don't want to give that to anybody. There are some things that have to be in place to give any user access to the database. There needs to be a database user, and that database user needs the right permissions assigned to it, and then that database user needs to be associated with an IAM policy, and then you have to give that IAM policy to an IAM role that your human user has. And so just have a protocol for that, so that you're not just having to come up with something in an emergency. This is a brief diagram of IntelliScript's break glass policy. We haven't had to use it yet, but we're glad it's there so that when the need comes up, we'll be able to follow that protocol. The last lesson learned is don't assume that you need AWS RDS proxy. One of the earlier speakers mentioned RDS proxy, and there's some organizations they're going to need it. It does connection pooling. I think it does other things as well. But connection pooling is necessary in many cases, and probably most cases, because databases have a connection limit. Once the database's connection limit is reached, then known clients can't connect. They're going to start crashing. So connection pooling is a way to just pool those connections together, so there's fewer connections to the database. So Aurora Serverless will scale its connection limit with the database. So it'll max out at 5,000 connections, which is a lot. I don't know what the limit is for regular standard RDS Postgres, but 5,000 is a lot more. So unless you have more than 5,000 concurrent consumers, you probably don't need RDS proxy. And I should also note that the NPG SQL library also does its own connection pooling. So if you monitor your database and look at the concurrent consumers, that'll give you a good idea of whether or not you're going to need RDS proxy. It is. I haven't used it. I've heard good things about it. It can be a little pricey. So those are all the lessons that I wanted to convey. Those were the most valuable things I learned throughout this migration.